this video, we're going to talk about how to find the range of the function 6 minus the square root of x plus 2. One of the most important things to notice is that they are asking for the range, not the domain. Remember that the range means essentially the things that y can be, so the outputs that you can get. You might also notice that the function we have here is a transformation of functions. Our parent function would be the square root of x, and it's been shifted to the left 2, since we are adding 2 underneath the square root right next to my x's. It's been flipped over the x-axis because of this negative sign out front, and it has been shifted up by 6 because of this 6 that you see right here. That might be hard to see. Maybe it would be easier if I wrote this in a different way. Remember, you can add in any order, and I am adding that 6 that you see up there. You can think of this as a plus 6 out front. There's no reason I can't move it to the end and write this as negative the square root of x plus 2 plus 6 instead, which might help with identifying the transformations that have occurred. Now, to me, the easiest way to find the range is to draw a rough sketch, which isn't hard to do when you're dealing with the transformation of a function. So I'm going to set up a few coordinate planes and we'll deal with each of the shifts that we see here. Here are my coordinate planes. In the first one, I'm going to draw a rough sketch of y equals the square root of x. Y equals the square root of x starts at the origin and then it goes off to the right, forming the shape that you see right here. The square root of x plus 2 then is thus indicating that I have shifted this graph to the left 2 units. So I'm going to draw exactly that. If I shift this to the left 2, what's going to happen? Well, I started at the origin. I'm going to move over 2, and I'm going to be located here. And I still have a graph that is going off to the right like so. The next transformation that occurs, and I'm working my way from the inside out here, the next transformation that occurs has to do with this negative sign out front. Remember, if you have a negative sign being multiplied out front, that means that your graph has been flipped, so to speak, over the x-axis. So, my next guy is going to have exactly that happening to it. So we were located at negative 2. And if I flip this over the x-axis, what that does is it's a perfect reflection. It's going to be going kind of curving off to the right forever, but kind of in a downward arc, as you see right here. Not a great graph, but it's good enough for my purposes. So this is reflected over the x-axis. The only transformation that we haven't gotten to yet then is the plus 6 on the end, which means we're going to take what we just got and shift it up 6 units. So we were hanging out at negative 2. We had an ordered pair there. And if I shift that up 6 units, 1, 2, 3, 4, 5, 6, I'm going to have an ordered pair roughly here at 6. And my graph is going to sweep off downward to the right like so. This right here is the final transformation. So this is shifted up 6 units. And this is my final graph. This is the graph of the full function that we see up here. How do I get the range then? Well, remember, range means the things that y can be. And you'll notice if you look at this graph, the highest y value I hit is 6. And since this is sweeping off down, it's going to take a long time, but this graph is going to keep getting smaller and smaller and smaller and smaller. It's eventually going to hit every single y value below this maximum y value of 6. So, if we want to talk about the range then, the range is going to be exactly this. The things y can be, well, there's a maximum y value that you can hit. That maximum y value is 6, and I put a bracket around it because I actually hit it. There's an ordered pair there, and I hit everything below it. So that forms the interval from negative infinity to 6.